Hello. I am actually going to talk about the Geth roadmap. We do not have we do not have our own rollup yet. Maybe next year. Geth coin incoming. Yeah, there we go. My slides are a bit lopsided. I'm sorry. Yeah. Let me just quickly introduce myself. So I'm Felix. I'm the current team lead of the Geth team at Ethereum Foundation. I became the team lead in the beginning of 2025 after a long tenure by Peter Schilagi. I guess most of you guys know Peter. He's still around and we have good ties, and so it's all good, but he's not with the Geth team anymore. And so for this presentation, I thought I'd give a little bit of an overview of what we actually did in 2025, as well as what we're planning for the next year. And I'm going to start by just quickly running through some of the highlights from the protocol development side. So in Geth, we have the interesting situation that we are very deeply involved with the development of the Ethereum protocol, as well as being a production-grade Ethereum client. I guess it is the case for like most Ethereum clients that they're some way involved with protocol development, but for us, since we're part of Ethereum Foundation, and Ethereum Foundation has a very large like research department as well, it's kind of like we always face, basically we have a lot of interface with like the people who are like really deep into, you know, like exploring the future and so on. So we often get to participate in the research in a direct way. For the Prague fork, which is already live, we worked a lot on history expiry, and for us this was a big undertaking because Geth, didn't really want to support it so easily. But I'm happy to say that we're now in a pretty good place. We worked also on the like era 1 files, which are sort of the backup. Like we thought a lot about these cases. Like, yeah, I mean, deleting the history is easy, but how do you actually get it back? Like, what if you really need to access the old history? How do you actually make that work? And yeah, we are still, I guess, working on that now. But for the Prague fork, we shipped like some kind of solution that we're happy with, where if you have pruned the history in your node, but you want to access the old blocks, you can dump era files containing the block range that you're interested in into a directory while the client is running, and it will automatically pick them up and allow you to access that part of the history. We also have a downloader tool for the historical files, so we feel like we did a pretty comprehensive job there. Another thing is like the EIP 7685. This is more like a consensus layer, execution layer interfacing thing. We worked a lot on that. We were deeply involved in the development of this EIP and kind of shaped it the way it is. And then finally, one of our team members, Matt, is the author of EIP 7702, set EOA account code, I think it is, with the set code transactions anyways. And we were very deeply involved with figuring out like how to make this supported in the mempool. Like, this was a big challenge, and we felt like we were sort of the client who was like most, like thinking the most about what's the impact of this EIP on the mempool. Is like not a trivial thing at all. And then for the Osaka fork, which is going to activate quite soon, it was kind of a boring fork, like on the execution layer. Like, there's some changes, but not really anything like super massive. And the main thing for us was just we spent a lot of time looking into our modular exponentiation precompile implementation, because that is like the slowest, by far one of the slowest parts in terms of the like gas per second. And so we ended up making some very deep optimizations in the Golang standard library to improve the performance of that. And so we're happy to say that it is no longer like such a bottleneck. So we feel like we're pretty well prepared for example, 60 million gas or 70, 80 million gas. We can handle it with this now, but it used to be that we wouldn't be able to, like this was the worst case. And then for on the feature side, we have two big things in Geth in 2025 that I would like to mention. First is the new log index implementation. We shipped this in version 1.15.6 around I think quarter 1, end of Q1. So this is an improvement to the performance of log querying, so ETH get logs and like ETH get filter changes and these types of methods. This used to be a very slow thing. So for example, if you wanted to query all ERC20 token transfers of an address over the last 2 or 3 years or something, this could take a long time. And with the new thing, you can just do it like in seconds. So we feel like it's a huge improvement. And as part of this, what I find very exciting is, so the index is useful for users right away, but we have big plans for this because the index is actually built so that the results of log searches can be proven against the blockchain. And we feel this is a big piece of innovation because, yeah, I mean, it's one of these things where if you talk to, for example, an RPC provider and you perform a log search, you cannot easily verify if they actually gave you the correct result. But with this index, if it is integrated into the Ethereum protocol, you can. And we feel like this massively reduces the trust in the providers that you have to bring. And I will be talking more about like trustless APIs later. In general, we are like very concerned about the trust aspects of the RPC interface, and we always working to reduce that. The other big thing that we shipped in 2025 was the new archive node in end of June in the version 1.16.0. So as you guys may know, Geth has 2 big modes of storing the Ethereum state. We have the hash-based storage and the path-based storage. And for the archive node, when we launched the path-based storage, we initially only supported this for the full node, and we had a long project where we basically tried to make it work for the archive node as well. And I'm happy to say that since June 2025, we now have the path-based archive node implemented. Just for reference, this is all like very similar to what other clients are doing. There's no like big magic here. Basically, it's like the Bisu Bonsai storage or the Aragon like storage. We basically do the same thing. It's just like there are some slight differences there, but honestly, this appears to be like the architecture that everyone is using nowadays. So yeah, we got that also. But then so what it means for the archive node is that used to be the archive node was around 20 terabytes and it's now 2 terabytes just about, which is a pretty significant improvement. Another feature on our side is the way it's implemented. You do not actually have to have the state all the way back to the Genesis block. By default, we keep the last 90K blocks, but it's a configurable range, and we made this change because we know that people do need the archive node, but not everyone needs like the real like full-on archive for everything. And I also just want to mention it because people often get confused, but like the archive node and accessing the logs is like 2 different things. So you don't need an archive node to query logs. And people often think like, yeah, I'm just going to need the archive node. I need everything, but that's really not true. Like by talking to users, we figured out that actually most people don't really need the archive node. They just need like one thing. And so this is, for us, we felt like by default, we don't want to have people sync all this stuff when they don't really, like, never going to need it. And then finally, the way it's implemented is using also these, like, a bit like the try logs mentioned by Gary this morning. And because of the way it's implemented, the archive part of the state, so the main state has to be stored in the SSD, and everyone knows that. It requires currently around 1 terabyte of SSD space, like including the history. But if you offload the history, then like the actual state is not that big. But the archive state is, which is about 1 terabyte of like extra data that turns your like full node into an archive node. This part can also be stored in the spinning disk with our implementation. It will give you, like, you don't need an SSD for that, but it will be slower. Obviously, if you have an SSD, the access will be much faster, but for many use cases, if you just have an occasional need to peek into the Ethereum state history, you don't actually need to use an SSD for that, and that can significantly reduce the costs of running the archive node as well. Right, so let me get on to 2026. I'm not sure how I'm doing on time. We will be working on the Amsterdam fork. We think that it would be good if Amsterdam came in summer 2026. It's a pretty ambitious goal, but we feel that like on the execution side, there are many small changes that can massively improve the user experience. And I just want to quickly highlight, we are very active in the development of block level access lists. It is the headliner feature for the Amsterdam Fork on the execution layer side. And then I'm just giving here some small highlights that are particularly important to us. One of the big features that we are absolutely rooting for, and I personally will really want to work on this, is the finally adding automatic logs for ETH transfers into the Ethereum protocol. So this is a feature that has been requested over and over for 10 years. People have always said, why can't I just do get logs and see when I received some ETH? And I feel like it is finally time to have this. So yeah, we will be rooting for that. We are also behind the gas repricing effort, and we'll be trying to optimize the client for the higher gas limit possibility. And then finally, I was mentioning it, the EIP 7545, Damn, yeah, the 7s and the 5s, yeah. 7. Okay. What I'm talking about, he knows what I'm talking about, even though it's the wrong number. So it's the trustless log index. Like I said, we really want to have that in the protocol, but it is a bit of a controversial thing among the clients, so we will be facing a bit of an uphill battle. Not every client is happy to have this because it is a significant amount of implementation work. I just want to say that like these are some of the things that are very important for us to work on in Amsterdam. And then finally, regarding the bigger features, I just want to say that we have started working on an entirely new execution layer API. So just in case you guys didn't have enough of the experimental GraphQL and like half-baked RPC methods, we're gonna come at you with yet another API. But no, I'm serious. So one thing that one thing we realize is that like it's kind of annoying. Like JSON RPC has been the default interface to the Ethereum nodes for a long time, but Ethereum nodes are actually the RPC API kind of came about as an interface between like the Ethereum browser 10 years ago and the node running on the local machine. And we feel like it's kind of time to rethink what is the interface that the clients should provide. We don't think that like the RPC should be deprecated or anything, and we do think there is a need to support it still, because obviously everyone's using it, but it's just something where we should rethink it from first principles and design an API that is like fully trustless from the start, and just exposes the minimum functionality that the client really has in the way that it can expose it best. And yeah, we have a prototype of it, and some documents that we're working on, and this is just something that throughout 2026 we will just keep looking into this. Another thing that we have sort of reconsidered is that we may finally add support for the parity call traces to get I know for some people this might be quite exciting, but this has been a long-standing feature request, and we feel like it might not actually be that hard in the end, and also maybe we can, like forget about all the politics from like 10 years ago and just add this feature. And then finally, we have looked extensively into, it's basically already done. The implementation of this is that we have the new archive node, but one downside of it is you can't actually get the proofs. And when we shipped the new archive node, we thought, oh my God, yeah, nobody needs proofs of historical state, but it's wrong, people need it. And especially the L2s and the sequencers, they need to have access to state proofs for some limited amount of history. So we have, like Gary from our side has implemented another layer in the archive node for supporting get proof, and we will try to roll it out in Q1 2026 so that everyone can finally get off of the like massive hash-based archive node. And then I still don't know how I'm doing on time, but I'm just going to quickly say we do intend in 2026 to be way more active in advancing the state of P2P networking in Ethereum. We do see that it's a bit of an like an area where not a lot of work has happened. So within the team, we now have many mempool experts working on like advanced designs for like the future mempool, especially regarding the blob scaling. We still dream about having some kind of decentralized storage solution for the chain history, even though Portal Network was unfortunately removed from Ethereum Foundation. And yeah, we are also working on a project to finally bring the Discovery version 5 topic index into production. So this will be some kind of improvement to the peer discovery, which is especially important for the smaller networks and or the L2 networks. And then finally, yeah, after having a lot of conversations with L2 forks of Geth and other projects using the Geth codebase, we feel that certain changes in the core could be very beneficial. Unfortunately, we have a hard time because of the way Go works. It's pretty hard to create like a generalized plugin interface, but we do want people to we do want to make the client more modular, so we have some ideas around that we're going to be following up. And then for my final slide, I just want to say people sometimes wonder how can we reach the Geth team. This seems to be a big problem actually that like people don't really know. And so I just want to mention it officially. So we do have an email address that you guys can use in case you want to inquire or have some business related. I mean, we are there to answer your emails. Please do not use Telegram. And we also have a Discord server. It's right there. Trust me, it's Discord link, not the scam. And we do answer questions there. And for all the power users and you know, B2B connections, we do offer you can offer you like a private channel there where we will be helping you with your requests. Yeah, that's it. Oh yeah, I do need that still. Yeah.
Yeah. Keep the mic there, and I put my glasses on this time, so I'll read the words correctly. Roadmap. So a couple of questions here. One, I think you answered in your question, but I'm going to ask it anyhow since it was one of the top voted ones. Why don't you support the trace namespace or parity that every other client supports?
Yeah, that's a good one. So traditionally, we didn't want to support this because the parity namespace requires us to store traces into the database. So we basically have to create an additional index that isn't tracked by the protocol at all, that contains all of the call frames of all transactions, and then they have some filtering and some indexing on top of that. And it just goes way back. That basically even back in the day we were saying, yeah, people should just use logs for this because logs are a protocol incentivized feature. And then I mean this API gives you access to an index that the protocol doesn't really care about. But yeah, I guess now it's.
Excellent. Let me.
Oh yeah. Should I answer that again?
Yeah,
he's
how
doing
is
great.
Peter doing?
Peter was at DevConnect. He was actually hanging out at our booth, like basically the whole day. And yeah, I mean, he's good. I mean, I can show his project. He has this like health-related device that he's been, publishing about. And I mean, I can attest, it looks great. He showed it around. He even left a couple of his circuit boards at our booth for people to. So yeah, I think Peter is okay.
All right, next one, which is not a question, but please, there was a request here, or maybe perhaps you can comment on. Can you make certain that you standardize the REST API from the ground up? Make it like Beacon API standard.
Yeah, that's honestly, the Beacon API is a huge inspiration for us. That's honestly why we got started with this project, because we looked at the Beacon API and we were like, yeah, damn, we want to be like that. This is like the REST API, the RPC API is kind of a mess. Like we are working on the standardization of the RPC API. I'm in these calls sometimes, and I do maintain also the RPC API testing and so on. And we will have a talk later today by Sebastian about like how bad the RPC is and the testing and everything. But I mean, we are working on it anyways, and it's not exactly easy. So yeah, I mean, I welcome you all to also like participate in the RPC standardization calls. We are there, and yeah, we wanna. These calls are like have very low participation. So yeah, you can absolutely be there.
All right. Next question here: is anyone publishing a block-proof archive?
Yeah, we thought about that, but it's big. Like things would be massive. So I don't really. I don't think anyone's. It would be just a huge data set, right? So yeah, I don't know. I don't know about that.
And then, do you work on a single binary execution client, consensus client?
Yeah, I mean, we want to. We had a project like 2, 3, 4 years ago. We had this project idea where we were like, yeah, we're just going to build a CL real quick, and it didn't. It wasn't that easy. So, but we do have a consensus layer like client, and I think this is something many people don't know. But I mean, you don't really need to run a consensus layer client if you don't want to stake. Like, okay, yeah, if you want to stake, you need the CL. But if you just want to follow the chain and like provide RPC, you don't actually need the CL. You can just run the like client, and it's built into Geth. Then we have a documentation page about it. We also have a standalone tool, BL Sync. So even if you're not using Geth, but you want to drive your other your other like execution layer client with our consensus layer like client, you can. It's supported as well.
And then last question here, do you have an estimated disk size of a new archive with ETH Git proof? 1 second.
I have it right here. Gary he knew this would be asked, so he posted. Yeah, I think it's going to be around 4 terabytes, right? I don't know where he is, but I think it's going to be around that. Yeah.
Okay, perfect. Perfect. And I think we're at time here, so we're going to leave the other 2 questions. But Felix, unless there's one that you're really interested in, you can go for it.
I just want to quickly answer the XX. Yeah, so we do have also something that I didn't really mention, but it's because it wasn't 2025, but we do have some kind of like plugin-ish interface. It's called the Live Tracer. So we have a hook system that will basically call, like you can write a Go-based plugin that is integrated into Geth, and that receives notifications about pretty much everything related to chain down to like EVM opcodes, but also like high-level events. And it is a stable interface. So yeah, I mean, people use this mostly for like indexing and so on. So there's a bunch of companies building on top of this. And yeah, I mean, if you have any questions, you should approach Sina. He's also the organizer of this event, and he is the maintainer of this interface. And yeah, it's there, but it's not as, it's a bit different from XX, but it's kind of same-ish idea.
Excellent, excellent. Well, another round of applause for Felix here.